All right, welcome back, everybody. So we are here to talk about this bicycle wheel problem, which you have thought about on Canvas. And the question here is, we've got a bicycle wheel, which is rolling along the floor to the right with a constant speed, and we want to know what the velocity of the bottom of the wheel is. So I'm just going to go ahead and draw us a quick picture. Here is my bicycle wheel. Maybe I'm going to put the ground on here. There's the ground. I want a flat ground. That'll work. And this wheel is going to be rolling this way. So I've got velocity v, which is going to the right. And of course, that means that the wheel is turning clockwise according to the picture that I have. Right. So I'll put a little vector here to represent, or a little arrow here to represent the direction that the wheel is rotating. What this means is every point on the wheel is actually moving in a different direction. So I could draw little actual velocity vectors like this that would tell me what direction each of these points is moving relative to the rest of the wheel. And what this means is that different points on the wheel have different actual velocities relative to the ground. So if I want to think about the bottom of the wheel, I have to add together the velocity of the wheel as a whole and the velocity of the bottom of the wheel. And it turns out that the velocity at the edge of the wheel has to be the same as the velocity of the center of mass of the wheel. And if that's true, then this vector here and this vector here actually cancel out for the bottom of the wheel. And my kind of combined velocity relative to the ground for the bottom of the wheel is actually going to be 0. The point where the wheel is in contact with the ground actually doesn't move, which is really cool. On the other hand, as a quick example, right, you can look at the top of the wheel and see that that point actually is moving quite fast. 2v, right? 1v from the center of mass and another v from the rotational motion. This overall is called rolling motion. In particular, we will sometimes talk about rolling without slipping, which is what you want bicycle wheels or car tires or that sort of thing to do. And anytime you have that happening, you can apply a mathematical condition which is that the velocity and the angular velocity are directly related by the radius at which you are going, which means that the farther out you are on the wheel, the faster you will be going, even if you have the same angular velocity. And that's an equation that we have seen before for relating translational and